Yeah, hi, hello. Today we'll try to learn a concept called a derivative, a very important chapter for calculus. So let us understand what do you mean by derivative, and the process of finding derivative is basically known as differentiation. So before we understand how to differentiate, let's understand what is derivative. Now derivative can have two different meanings. One I would say physical meaning, and the next one I can say geometrical meaning. So if I say physical meaning, it represents nothing but rate of change. Now, when I say rate of change, then obviously it won't be a simply rate of change. It will be a rate of change of one quantity with respect to what the another quantity with respect to other quantity. That I can say it's a physical meaning. Now, when I say geometrical meaning, it is nothing but basically slope of the tangent. Now, one should know both of these meaning because this will be helpful in a chapter called application of derivative. So derivative means rate of change of one quantity with respect to the other quantity, and another meaning of derivative can be slope of the tangent. Now let us try to understand each one of these meanings one by one. So when I say rate of change of one quantity with respect to another quantity, then you can understand, let's take an example. So for example, we know that displacement of a displacement of a particle depends on what? T. So basically S is a function of T. Now when I say S depends on T, so I can say what? S is a function of what? T. S is a function of T. Now if you want to know how fast the displacement and how is the displacement changing whenever there is any change in time, then you can find basically derivative of S with respect to T that can be represented right like this, ds over dt. It means what? Derivative of S with respect to T. Derivative of S with respect to T. And we all know that if you differentiate displacement with respect to time, the thing which you get is known as velocity, more accurately, instantaneous velocity, or I can say simply velocity. So if you differentiate or if you find the rate of change of displacement with respect to time, you get what? Velocity. Right? Likewise, we can have another example. Like we know that cost of a function depends on basically the demand of the function, right? Cost of the function, I can say somewhat depends on demand of the function. So if I say C is the cost and D is the demand, so I can say cost will be the function of what? Demand. If the demand is high, cost will be higher, and demand is low, the cost will be low. So we can find dC by dd, that is rate of change of cost with respect to what? Change in demand. So this can be another example. So in general, usually we take most of the example where we say y is a function of x. Now when I say y is a function of x, that means we understand y depends on x. Now when you say y depends on x, it means if there is any change in x, there will be a corresponding change in what? Y. Okay, so in general, this is how we write y equals to what? F of x. So y equals to f of x, that means y is a function of x. And then how will I write derivative of y with respect to x? The way is dy over dx. Derivative of y with respect to x. This denotes what? Derivative of y with respect to x. Or you can simply write f dash of x as well. Either you write dy by dx or you write f dash of x. Both represents what? Derivative of y with respect to x. Okay, and with respect to the geometrical meaning, we can understand that dy by dx is nothing but basically change in y over change in x. That's how we find the slope of any line. So it represents what? Slope of the tangent as well. Now, after knowing how do you represent derivative and all, the question comes, how do you differentiate? For that, we have some set of formulas which we will be following to find the derivative of different kind of functions. Okay. So let us note down all the formulas which we have to find derivative of various functions. So we are going to see different set of formulas for different kind of functions. So let me draw a line first. On one side, we'll write the function. On another side, we will have what? Its derivative. So let's say y, and we have what? Dy by dx. Okay, or someone can say y equals to f of x, or I can write f dash of x. Okay, starting with a very in general function, x raised to n. If we have x raised to n, very important here to understand that x is a variable and n is a constant. Now, when I say n is a constant here, that means here n can be any number. So if we have any function like x raised to n, derivative of that function is given by the formula n times x raised to n minus 1. N times x raised to n minus 1. Now let's take some example based on this. So if we have, let's say x raised to 2. So if you take x raised to 2, here you see that the value of n is what? 2. So if we apply the formula, we will be getting 2 times x raised to 2 minus 1, which will finally give us what? 2x. Likewise, we can have another example. Let's say if we take an example of 1 over x raised to 3. Now this is 1 over x raised to 3, as we know. Let me change the color first. As you know that using the rule of indices, you can write this as x raised to minus 3, right? Now, as I said, while I'm writing the formula, this formula works for any value of n. So I can apply the formula for x raised to minus 3 as well. Here we notice that the value of n is what? Negative 3. So if we apply the formula, we get minus 3 times x raised to minus 3 minus 1, which will finally give us minus 3 times x raised to what? Minus 4. Okay. Now, what if you have something like, let's say, x raised to, let's say, root x. I mean, a root x can be written as x raised to half. Okay, so this shoots in the form of x raised to n. So we can apply the formula again. So what do we get? Half times x raised to half minus 1, and half minus 1, as we know, it is nothing but minus half. So finally we get half times x raised to minus. I think I took enough example based on formula x raised to n. So finally, the derivative of x raised to n is what? N times x raised to n minus 1. Now going ahead with the next formula, which is I take k, simply k. Now what does k represent there? Where k is constant. If you have to differentiate a constant, what should be the answer ideally? Now I can directly write the formula, but before I write the formula, I want to go through the definition of derivative. What did we say while defining derivative? We say that it is rate of change. It is rate of change of one quantity with respect to the other quantity. Now, when we talk about constant, now what does constant mean? Constant mean what? There's no change, right? Now, if there is no change, how can you find rate of change? So that means rate of change has to be what? 0. So ideally, the derivative of any constant will be what? 0. So if you see any alphabet, unless they specify that it is not a constant, you will be taking the derivative. You will be taking the derivative of that alphabet as what? 0. Okay. Going ahead, writing the next formula. If we have function in the form of, let's say, ln, let's take a function called ln x. So what is derivative of ln x? Derivative of ln x is 1 over x. Now here there can be a trap as in, what if I tell you what is derivative of ln2? So if I ask you derivative of ln2, and if you're in your mind, if you're thinking the answer is 1 over 2, then you're wrong. It is not 1 over 2. Now you know ln2 has fixed value, although we know it or not, that doesn't matter. But we all know that it has fixed value. That means the derivative has to be what? Not 1 upon 2, it has to be what? 0. So avoid that trap whenever they give you such kind of thing. I hope till now everything is clear. Okay, let's go ahead and see next formula. If derivative of e raised to x, where e is a fixed number, derivative of e raised to x is what? E raised to x. Again, the trap can be like, what if I ask you derivative of e raised to 2? Don't say the answer is e raised to 2. It has to be what? 0. Now you can have something like a raised to x as well, where a is any base greater than 0. The formula for that is a raised to x times ln a. Likewise, let's take some example of a trigonometric function now. Derivative of sine x. Derivative of sine x is what? Cos x. And in this case, again, if I ask you what is derivative of sine 30, don't say the answer is cos 30. What will be the answer? Sine 30 has fixed value, so answer needs to be 0. Very important to note that. We can have the formula for derivative of cos x, which is negative sine x. Okay. Then you can have formula for derivative of tan x, which is sec square x. Okay. Likewise, we can have formula for derivative of sec x, which is sec x tan x. And we can have formula for cosec x as well, which is negative cosec x into cot x. Now there are some different set of formulas as well for inverse function. Derivative of sine inverse x, derivative of cos inverse of x, and derivative of what? Tan inverse of x. The derivative of sine inverse x is 1 over root of 1 minus x square. Derivative of cos inverse x is 1 over root of 1 minus x square. Derivative of tan inverse x is 1 over 1 plus x square. You can have formula for derivative of cot inverse of x as well, which will be negative 1 over 1 plus x square. Okay, then you can have for sec and cosec as well, sec inverse and cosec inverse x as well, but we hardly use it. Not that form. So these are some set of formulas which will be helpful for us while differentiating the different set of functions. Now, after going through all these formulas, let us understand the rules of derivative. Now, what are the different rules of derivative? So next topic to focus is what? Rules of derivative. Now, what are different rules we need to follow while differentiating? Okay. So first rule, if you have, let's say, y equals to f of x plus g of x. plus or minus this. Now, if you have more than one functions together, okay, f of x, it can be plus or minus g of x. Then how do I differentiate? Then we write our dy by dx as dy by dx will be what? We differentiate the first function, that is derivative of f of x, and whatever sign is there, plus minus, and then we differentiate the what? Second. For example, if you want to see an example, let's say if I ask you y equals to x plus sine x, then dy by dx, ideally it should be derivative of x plus derivative of what? Sine x. Now to find derivative of x, you can apply the formula of x raised to n, which is x raised to 1 in this case. Derivative of x is going to be 1. If you apply that formula, you will get the answer as 1. And derivative of sine x is nothing but cos. So the final answer will be what? 1 plus cos. I hope this rule is clear. We individually differentiate and we put the sign, whatever sign is there in between. Now it's not necessary that we'll always have two functions. You can have more than two functions as well. Now we saw what if we have plus minus. Another case can be what if we have multiplication in between, multiplication sign in between. So if we have y equals to f of x times g of x, okay, two different functions together, and you want to differentiate it. Okay, before I do that, let's take a different scenario. If we have a function and a constant together, so k times f of x. So if you have a function and a constant together, as we know that the derivative of constant is 0, so sometimes people mistake it and they write answer as 0, which shouldn't be the case. When you have a constant and a variable together, then final output is not a constant, it's a variable. So the derivative is not going to be 0. Then the question is, how do I differentiate? So to differentiate, we do what? We keep k apart. So we keep k aside, okay, and just differentiate the variable part. That is derivative of what? F of x. So if you take an example, so let's say that if you take an example of y equals to 4 times e raised to x. So the differentiation will be dy by dx equals to 4 will keep aside, and we just differentiate what? E raised to. And that is, as we know, from the formula, the derivative e raised to x is e raised to x. So the final answer will be 4 times e raised to. Okay, so if we have a constant and a variable together, what do? We keep constant aside and just differentiate the variable part. Okay, before we go ahead, let's take an example which has both this rule combined. So let's say if we have y equals to x cube plus, okay, x cube plus 5 over x square minus what? Let's say cos x. Okay, so what should be the answer? How will we differentiate it? So dy by dx will be derivative of x cube. I'm just writing it. You don't need to write it all the steps. And here you have c 5 over x square, which 5 is a constant. So I'll take 5 aside and we'll take derivative of 1 over x square. Now 1 over x square can be written as what? X raised to minus 2. Why am I writing in this form? So that I will be able to apply the standard formula which we have, and derivative of cos. So derivative of x cube, if you apply that rule, x raised to n, which says n times x raised to n minus 1. So it will become 3 times x raised to 3 minus 1 plus 5 times here, minus 2 comes down, minus 2 times x raised to minus 2 minus 1, and minus as it is, derivative of cos x is minus sin. So finally the answer will be 3 times x raised to 2. This will be negative 10 times x raised to minus 3, and this will be plus sin. You can keep your answer as this. This will be our final answer. I hope till now everything is clear based on the rule of sum and when you have a constant and a variable together, how do we differentiate such kind of function? Now, then we have a very important rule, something known as product rule. Now, what does this product rule says? If you have two different functions in multiplication form, how do you differentiate? That is what we will be saying now. Product rule, okay, also known as U into V rule as well. U and V are the two different functions together. So let's say that if we have y equals to U times V, where U and V are the two different functions. Okay, so the product rule says that derivative of y will be, you keep U as it is, differentiate the second function, and then keep V as it is, differentiate the first function. So dy by dx is nothing but V times dv by dx plus, sorry, U times dv by dx plus V times du by dx. Okay, let's take an example. Suppose you have y equals to x times sine x. Okay, let me take x square times sine x. How will I differentiate? So you can see that you can assume this as your first function and this as your second function. So what does the rule says? You keep your first function as this. Now it's not necessary that you keep first function as this. You can differentiate the first, keep the second one as it is, and then keep the second as it is and differentiate the first. You can do it in any order because we have a plus sign, so it doesn't really matter. So we'll keep x square as it is, and we have to differentiate what? Sine x. And then plus, I'll do what? Sine x as it is, and we'll differentiate what? X square. So we will get x square as it is. Derivative of sine x would be cos x, and then sine x as it is, and derivative of x square is nothing but what? 2x. So this will be our final answer. X square times cos x plus sin x times 2x. I hope it's clear. Now, the way we have product rule, we can have something known as quotient rule as well. Now, let's understand what is this quotient rule. Also known as U by V. That means we have one function above the another function. So if we have y equals to U over V, then how do we differentiate? Then the formula says dy by dx is nothing but V as it is, derivative of U minus U as it is, derivative of V over V. Now, very important to know that rather than writing du by dx and dv by dx, one can simply write u dash and v dash. Okay, so this formula in shorter form, we can write derivative of u by v is nothing but v u dash minus u v dash over v square. So even if we write like this, it exactly means nothing. Right? Let's take one example based on it. So, example, let's say that we want to take y equals to, let's say, ln x over x square. Ln x over what? X. So you can see that this is our u and this is our v. We cannot interchange in this case because there's a minus sign. So we have to be particular what is our u. So you can see your u is nothing but ln x and v is what? X square. So you can find u dash. What will be u dash? 1 by x, derivative of ln x is 1 by x. And you can find v dash, which will be your 2x. Now just put into the formula. So finally, dy by dx your v as it is, that is x square as it is, times u dash, which is 1 by x, minus u as it is, which is ln x as it is, times v dash, which is 2x, over v square. So x square, the 2 square. Right? We can cancel one power. So finally,